Okay, two more labs left to go. So the next lab that I'd like for you to know is one that I kind of renamed it. I'm calling it energy and motion. How does energy produce motion? And so this was the one where you were out in the hallway and you had the ramp, and then you took the ball, you put it on the ramp, you measured the height above the ground, and then you let it go. And then when it got to the bottom of the ramp, you measured the distance that it rolled sideways. And you also measured the amount of time it took to roll that distance. So that was the experiment. So what kinds of measuring devices did you use? Well, you used a measuring tape, you used your cell phone to measure time, and then you also used that electronic mass scale to measure the mass of the object. So those would have been three measuring devices that I'd like for you to be able to know. So what were the concepts? Okay, what is potential energy? What's the formula for gravitational potential energy? Could you calculate the potential energy of an object? So you got to know the height that it's at, you got to know its mass, and then you got to know little g, which is 9.81, which I would give you on the exam. And then you could calculate the gravitational potential energy in joules. All right, do you know what kinetic energy is? So what's the definition of kinetic energy? What's the formula for kinetic energy? Okay, could you solve a problem where if I gave you the mass and I gave you the speed, could you calculate the kinetic energy? Okay, then there was conservation of energy. So what does that mean? To say that energy is conserved. So how did we do that in the lab? Well, when the ball was at the top of the ramp, all the energy was in what kind? When the ball rolled down to the bottom of the ramp, what kind of energy did it turn into? So we were able to calculate the final speed of the ball when it got to the bottom of the ramp. So go back in your notes and go back into that lab and look at that. Okay, then we also talked about what work was. So work is going to be force times distance. And then we talked about what Newton's second law is, force equals ma. And we use that to calculate the acceleration of the ball when it got to the bottom of the ramp. So when it was at the bottom of the ramp and it started rolling on the floor, it was de-accelerating. And we were able to calculate that de-acceleration. And then what did we do with it? Well, we used it to find the amount of time that it took the ball to come to a stop. And how did we do that? All right, so we're going to use the how far equation, which is the final speed is equal to the initial speed plus the acceleration times time. So we know that the final speed was what? The ball came to a stop. All right, so we know that. We know the initial speed because that would have been the speed that we got from conservation of energy. It was the speed the ball had at the bottom of the ramp. Okay, the hard part was getting that acceleration. And so I'll have you go back into the lab and figure out how did we calculate the acceleration of that ball. So we know V final, we know V initial, and we know A, and we solved it for the letter T, and then we compared it to the amount of time that we measured it to be with the stopwatch. All right, so that was probably the most complicated lab that we did this year. So go back and read through that lab. And then the last lab that we did this year was on simple machines. So the devices that you used was a ruler. We also used those mass sets, and then each of the discs were 50 grams. Remember that? So there was a whole bunch of discs that we used for our weights for that. And then we used a spring scale. So hopefully you remember how to measure the weight of an object using a spring scale. That could be on the exam. And the concepts that we used was work, and the idea that you put in a certain amount of work into a machine, and then a certain amount of work comes out. And by conservation of energy, those two are equal to each other. So the work that goes in is the same as the work that comes out. Now that's assuming that it's a perfect machine and there's no loss of energy due to heat. That gets into efficiency, and I'm not going to have you know that for the exam. So there were 3 kinds of machines that we did. We did the ramp, the lever, and then the pulley. So one of those is going to be on the exam. I won't tell you which one, but it's either going to be a ramp problem or a lever problem or a pulley problem. Now they all work the same way. It's going to be a force that you put into the machine times the distance that goes into the machine has to equal the force that comes out and then the distance that comes out. So for the ramp, the force in is going to be the force that you push up the ramp with times the length of the ramp equals the weight of the box or whatever you're trying to push up the ramp multiplied by the height of the ramp. Okay, for the lever, that was the one with the teeter-totter. So that you measure the force that you push down on one side of the teeter-totter multiplied by the distance to the pivot point has to equal the distance from the pivot point over to where the box is at multiplied by the weight of the box. And then what about the pulley? The pulley was kind of complicated because it depends on how many strings are holding up the weight. So you remember that we did one with one string going over and then attaching to the weight. Well, that's not a very good pulley because you have to use exactly the same amount of force to lift it, and you have to pull exactly the same amount of rope. So then we did the double pulley, where the rope went over the top one and then it went under the bottom one and then it attached to the top one. So now there are 2 ropes that are lifting the weight. So then that means that you only need to apply half the force, but what's the bad news? You gotta pull twice as much rope. And then we did the triple one. So I'm going to let you review the lab for the triple one and to see how that one worked. So there you go. So there's your review of all these different labs. Study, study, study. It's 5% of your grade, which doesn't seem like much, but it's a letter grade, basically. If you don't do well on this, it could be the difference between an F and a D or a D and a C or whatever. And so do your best on it. I will provide you with all the formulas, but you will not get to use a note card for this exam. All right, until you take the exam, I'll see you.